Europe's robotics era has finally begun. For more than a decade, humanoid robots were framed as a race dominated by the United States and China. Silicon Valley startups promised general-purpose robots that would change everything, while Chinese manufacturers focused on rapid iteration, cost reduction, and scale. Europe, meanwhile, looked slow, fragmented, and almost hesitant. It had world-class industrial automation companies, but very few headline-grabbing humanoids. That changed abruptly in early 2026. In the span of just weeks, Europe unveiled a lineup of humanoid robots that did not just look competitive on demo videos, but felt fundamentally different in philosophy. While the United States and China chased speed, spectacle, and valuation, Europe arrived with something quieter and far more dangerous: robots designed to work from day one. Now, in the United States, companies like Tesla with Optimus, Boston Dynamics with Atlas, and Figure AI have pushed humanoids into the public imagination. These robots are impressive, showing dynamic walking, heavy lifting, and growing autonomy, but most of that progress remains inside controlled labs, staged warehouses, or tightly supervised pilot setups. The promise is clear, yet large-scale industrial deployment is still cautious and limited. China took a different route. Companies like Robotics, Tech, and Agile focused on speed and cost. Chinese humanoids are improving rapidly and getting cheaper fast, but that scale-first strategy often trades off depth, with dexterity, long-term reliability, human acceptance, and complex workflow integration still catching up. Europe watched all of this unfold, and instead of rushing to compete on the same terms, it waited. That patience now looks intentional. Germany fired the first serious shot. When Agile Robotics revealed Agile 1, it did not feel like a response to Tesla Optimus or Boston Dynamics Atlas. It felt like something built for a completely different purpose. Agile 1 is a full-size industrial humanoid designed to operate where traditional automation fails, not on open warehouse floors built for robots, but in human-designed factories filled with narrow paths, legacy machines, and unpredictable layouts. This is the environment European industry actually operates in, and Agile 1 fits into it naturally. What separates Agile 1 from most Western and Chinese humanoids is how it thinks. There is no teleoperation, no scripted motion library, no human quietly guiding it from behind the scenes. Agile 1 runs on end-to-end AI trained in the real world. Its intelligence comes from reinforcement learning inside physical environments, not synthetic simulations. That is why its demonstrations look mundane instead of cinematic, picking up M3 screws, handling small tools, touching capacitive screens accurately. These tasks are incredibly difficult for robots because they require perception, force control, and decision-making at a human scale. Agile 1 performs them without hesitation. In contrast, Tesla Optimus has shown impressive progress in walking, carrying objects, and general manipulation, but fine motor skills at this level are still emerging. Chinese humanoids can move quickly and cheaply, but precision tasks involving small components remain limited. Agile 1 quietly excels at the exact operations factories care about. It collects materials, loads and unloads machine tools, performs picking and placing, handles equipment, and executes precision operations that normally require skilled human labor. Even its head and eyes serve a functional purpose. They communicate intent. In real factories, humans need to understand a robot instantly. Agile Robotics understands this because it comes from industrial automation, not consumer tech. Manufacturing begins in Germany in early 2026, and instead of shipping a static product, Agile 1 will be trained on-site at customer locations. The robot improves by working, not by updating firmware in a lab. This alone places it ahead of most United States and Chinese competitors in terms of real-world readiness. Italy followed Germany, but with a very different angle. During AMD's CES 2026 keynote, Generative Bionics unveiled GENE.01, a humanoid that challenges how intelligence should exist inside a robot. While United States companies tend to centralize intelligence in massive models and Chinese firms prioritize fast execution, GENE.01 introduces the idea of physical AI. Intelligence is distributed across the body, touch is processed locally, reflexes emerge at the limb level. This reduces latency and makes interaction safer and more natural. This approach directly addresses one of the biggest problems in humanoid robotics today: over-centralization. When everything depends on a single brain, systems become fragile. GENE.01 avoids this by letting the body participate in intelligence. Powered by AMD embedded CPUs, GPUs, and FPGAs, it processes perception, motion, and adaptation simultaneously. Compared to Atlas or Optimus, which still rely heavily on centralized control architectures, GENE.01 feels closer to a biological system. Italy also focused on something most competitors treat as secondary: acceptance. American humanoids often look utilitarian or experimental. Chinese humanoids focus on function and cost. GENE.01 Humanoid.01 is deliberately designed to look balanced, calm, and approachable. Its proportions and posture are engineered to feel familiar. This matters in environments where humans and robots must collaborate closely. Backed by an $81 million funding round with AMD as both partner and investor, Gene.01 is moving through industrial demos in 2026, with a commercial launch targeted for late 2026. It is not chasing viral moments, it is building a foundation. Italy did not stop there. Oversonic Robotics introduced RoBee, a humanoid already moving into early deployments. RoBee represents Italy's answer to cognitive autonomy. Powered by Intel Core Ultra processors, it performs on-device AI inference without relying on the cloud. This immediately gives it an advantage in reliability and privacy compared to many United States humanoids that still depend on remote computation. RoBee is tall, physically capable, and designed for bimanual manipulation and fast decision-making. What makes RoBee especially notable is its dual focus. In industrial settings, it handles complex workflows that require judgment, not repetition. In healthcare, variants assist patients with neurological conditions like Alzheimer's and Parkinson's, adapting in real time. Very few humanoids in the United States or China are attempting to bridge industrial and healthcare domains simultaneously. RoBee does so deliberately. With partnerships involving Intel and ST Microelectronics and expansion into the United States through clinical trials, RoBee quietly positions Italy as a serious global competitor, not just a regional innovator. While Germany and Italy were unveiling new machines, Poland delivered something that changed the conversation entirely. Clone Robotics unveiled Protoclone, a humanoid that does not just improve on existing robot designs, but rejects their core assumption altogether. Instead of electric motors, rotary actuators, and rigid linkages, the same foundations used by Tesla, Boston Dynamics, and most Chinese humanoid manufacturers, Protoclone is built around synthetic muscles. This single design choice places it on a completely different technological trajectory from the rest of the global humanoid field. Protoclone's movement is powered by more than 1,000 artificial muscle fibers arranged in muscle tendon units that closely mimic human anatomy. These muscles contract, stretch, and distribute force in ways electric motors simply cannot. Its internal structure mirrors the human body, with all 206 bones replicated in a polymer skeleton, connected by artificial ligaments and tendons that behave like their biological counterparts. Instead of stiff, segmented motion, Protoclone flexes and flows. Joints absorb force naturally. Movements look continuous rather than mechanical. This is why early videos of the robot unsettled so many viewers. It did not move like a machine learning to imitate humans. It moved like a synthetic organism learning to exist. From a technical perspective, this approach solves problems that motor-driven humanoids still struggle with. Muscle-based actuation offers inherent compliance, meaning the robot is naturally safer around humans. Force is distributed across the body rather than concentrated at gearboxes. Precision and softness coexist, allowing delicate manipulation without sacrificing strength. While companies in the United States and China are pushing software harder to compensate for rigid hardware, Clone Robotics is addressing the problem at the physical level. Protoclone is still evolving, particularly in autonomy and full-body coordination, but its direction is unmistakable. Where others are refining machines, Poland is attempting to recreate biomechanics. If humanoid robotics is ultimately about matching human capability, Protoclone may be closer to the endgame than anyone expected. Meanwhile, the United Kingdom-based humanoid company built HMND-01 Alpha in just 7 months, the fastest developed full-scale humanoid robot to reach autonomous industrial operation in the world. At CES 2026, HMND-01 Alpha was not hidden behind safety cages or running a scripted demo. It operated live at the Schaeffler Group booth, performing autonomous bin picking of metallic bearing rings from cluttered industrial bins. This task is notoriously difficult because parts are unsorted, overlapping, and reflective, conditions that break most traditional automation. Alpha identified the rings, picked them autonomously, and placed them onto a buffer table exactly as a real factory would before feeding an assembly line. There was no teleoperation and no human correction. Press one button, and the entire workflow ran end to end. Physically, Alpha stands 220 centimeters tall and moves on a wheeled base, reaching speeds of up to 4.47 miles per hour. But why wheels? Well, the wheel design was a deliberate industrial choice. In factories with flat floors, wheels are more stable, safer, and integrate faster than bipedal walking ever could. It carries bimanual payloads of up to 33 pounds, reaches from floor level to 2 meters high, and accesses shelf depths of up to 60 centimeters, reaching real warehouse and production layouts. It operates with 29 active degrees of freedom and uses AI-driven, end-to-end reasoning rather than scripted motion. But how they made it possible to complete all these features in less than a year when others take decades? The team behind this effort is made up of engineers and researchers who had already lived through the hardest parts of Humanoid. Why? Its team includes alumni from Apple, Tesla, Google, Boston Dynamics, Sanctuary AI, and NVIDIA. It is clear that what ties all these European robots together is not speed, hype, or valuation. It is intent. Europe may have arrived late, but it arrived prepared. It waited until humanoids could integrate into real systems. In just 1 month, Europe revealed industrial pragmatism from Germany, physical intelligence and cognitive autonomy from Italy, and biomimetic ambition from Poland, and a second wave of automation driven by intelligent machines grounded in reality. So what do you think? Will Europe actually beat the United States and China in the humanoid robotics race? Or is this just the beginning of a longer battle? Comment your take. And if you want the real story behind the world's fastest moving AI and robotics breakthroughs, make sure to like and subscribe to Evolving AI. And if you want to support the channel directly, consider joining the membership so we can keep making deep dive videos without ads.